The screen is visible.
Yes, sir.
So good afternoon, everyone. So in the previous lecture, we have completed the poles and zeros of a network function. We have seen the different aspects, different points regarding the poles and zeros of the given network function N of S. And after that, we have discussed the necessary conditions required for driving point functions. So there were 6 necessary conditions we have discussed yesterday in the previous lecture. So in the network function, there are the 2 types. Already you know that. One is the driving point function, and second one is the transfer functions. So yesterday we have seen the discuss the necessary conditions for driving point functions. Now today we are going to start the necessary conditions required for transfer functions, and then after we are going to start the time domain behavior of the given system based on the pole zero plot. Okay, so we can start today's. Also the theoretical part will be there most of the time, and in the next lecture we are going to solve numerical examples. Okay, if possible today we can solve one example based on the time domain behavior. So the first we can complete it, the necessary conditions for transfer function. So this point is very important from MCQ point of view. Okay, so necessary conditions they can ask through MCQ. So necessary conditions for transfer function, for driving point function, they can ask in the upcoming examination, university examination. So you know that the network function N of S is polynomial of P of S and Q of S, that is the ratio. So for driving point function, there will be the different functions Z11, Z22, Y11, Y22. So those are the driving point function. Whereas the transfer functions, voltage transfer ratio, current transfer ratio, transfer admittance, transfer impedance. Okay, so all the definitions we have discussed already in this chapter. So one by one, we can discuss the conditions here. The first one will be the coefficients. The coefficients in the polynomial. The coefficients in the polynomial P of S and Q of S. Q of S and Q of S of the network function N of S. Of the network function N of S must be real and negative. Must be real and negative. Must be real and negative. So you already learned the first same point in the driving point function. There will be the word real and positive, and here it will be real and here also it is positive only, not negative. Real and positive. First point is same in transfer function as well as driving point function. Must be real and positive. That is example I have given. S is equal to 0 or S is equal to -1. Okay, like this. Next, second conditions for the coefficients in the Q of S must be positive. That already given. Once again, we can, because with respect to poles we are talking, the coefficients in Q of S is positive. Almost these are the same. Third one, complex poles and zeros must occur. This is also same point compared to driving point function and transfer function. Complex poles and zeros, complex poles and zeros must occur in conjugate pairs. in conjugate pair. So that already you know that example we already discussed that. Next, the real part of the poles must be negative or zero. The real part of the pole, the real part of the poles must be zero or negative. So example, I will take different example here. S is equal to 0. This is also acceptable. S is equal to -1. This is also acceptable. S is equal to like this plus minus 2j suppose. So whether this is real part is 0, no? By default, if no real part is mentioned means 0 will be there. So it can also write like this 0 plus minus 2j. So this is also acceptable. Then S is equal to -1 plus or minus 3j like this. So real part is here minus. Okay. So we can like this, we can take the example. Means it should not be like this. S is equal to 1 plus or minus 3j like this. So this is not acceptable because it is a positive. The real part is positive here. So this is not acceptable. That you can try to understand here. Because the real part must be negative for transfer function for the poles. Now next one, these are the 4 necessary conditions for transfer function. Next, 5th one, the degree of P of S, the degree of polynomial P of S independent of degree of Q of S. So if you're comparing this point with respect to driving point function, so what is the condition in driving point function? The highest degree of P of S and lowest and highest degree of Q of S may differ by 0 or 1. त्यांच्या दोन्ही मधला हायेस्ट डिग्री मधला डिफरन्स किती पाहिजे? एक तर 0 किंवा 1 जास्तीत जास्त. तसंच लोअर डिग्री मध्ये. But for the transfer function there should not be any condition, any restriction between degree of P of S and degree of Q of S. त्याच्यामधला डिफरन्स कितीही असू शकतो. Are you getting my point? So that is the difference here between this point with respect to transfer function and with respect to driving point function. Now next, 6th one, the polynomial Q of S may not have any missing term between highest and lowest degree unless all even or all odd terms are missing. All odd terms are missing here. So in case of driving point function, it is applicable for both polynomial P of S as well as Q of S. म्हणजे जर तुम्ही ड्रायव्हिंग पॉइंट फंक्शन कन्सिडर केलं तर polynomial P of S and Q of S may not have any missing term between highest and lowest degree unless all even or all odd terms are missing. So example, I will take polynomial Q of S. I will take like this. So S square plus 1. So this is acceptable because here odd terms are missing but even terms are present. Then S cube plus 3S square plus 2S plus 1. So no missing term here. So this is also acceptable. Next here, if you're taking example here, suppose you are taking s cube plus 2s square plus 4. So here the even terms are missing here. Yes, okay, even terms are present, s raised to 2 and s raised to 0 is present, but odd terms are missing, so this is not acceptable. So with respect to q of s, we are talking about the polynomial q of s. So seventh point, the polynomial p of s, the polynomial p of s may have the missing terms, between highest and lowest degree. म्हणजे पी ऑफ एस ला चालेल, पी ऑफ एस बघायचंच नाही किती कुठले टर्म्स प्रेझेंट आहेत कुठले नाही आहेत, दॅट इज ऍक्सेप्टेबल. सो एक्झाम्पल, पी ऑफ एस इज इक्वल टू एस क्यूब plus 2s square plus 3. So this is acceptable. Here even terms are present but odd terms are not present. All odd terms are, only s cube is present but s raised to 1 is not present. So even though that is acceptable for polynomial p of s. So this is the seventh point. So these are the necessary conditions required for transfer functions. So I will give the 2 minutes for you people. You can read 7 necessary conditions. You can read it. If any conditions you not understood or any point you not understood, you can ask. Okay. So take a 2 minute and read it, everyone. Okay, any questions?
Sir, can you explain point number 1 again?
Point number
1.
Okay. The coefficients. Okay, so here example I will take differently here. So example, we can take polynomial here because they ask the coefficients. म्हणजे coefficient p of s मी इथं पोल सांगितले. p of s is equal to s cube plus 2s square plus 3s plus 1. Suppose this is the p of s. So here coefficient all are positive. Yes or no?
Yes, sir.
Coefficient of s cube is 1, that is plus 1. Coefficient of s square is plus 2. Coefficient of s is plus 3. And here constant term, that is the coefficient of s0, that is the 1. So this is acceptable. So suppose example we are taking like this. P of s, q of s, it is applicable for both. So p of s is suppose like this. S cube minus 2s square plus 4s plus 2. So this is acceptable or not according to this point?
Not.
No.
Yes, because here for s square term the coefficient is negative. I understand. For s square term the coefficient is minus 2. So that is not acceptable for transfer function. Now understood this point? Very good question.
Yes, sir.
Okay. Any another questions? Any another doubt? Actually, these are the not examples. Okay, so this type of example we can take. This is applicable for both polynomial P of S and Q of S. Can we move towards the next point? Yes or no?
Yes, sir.
Yes, sir.
Okay. Okay. So next point will be the time domain response or time domain behavior from the pole zero plot. So this is the last point in this chapter we are discussing. Time domain response, time domain response or behavior, time domain response or behavior from pole zero plot. So time domain response or behavior of what? Of the network function N of S from the pole zero plot. Okay, so how to plot the poles in zero already we have learned. We have discussed we have taken the 3 examples to plot the poles and zeros, including complex conjugate poles, complex conjugate zeros. We have taken the example. So time domain response or time domain behavior means what? So network function is in S domain. Okay, network function is what? In S domain, that is Laplace domain, we can call it as. We can plot the poles and zeros, and from the poles and zeros, we can find out the time domain response means we are using the inverse Laplace. Okay, already in mathematics, whether this point is covered, Laplace transform.
Yes, sir.
Okay, means there is no problem. So we are not using all formulas, but we request 2 to 3 inverse transform formulas. That is sufficient. So time domain response means what? We are converting S domain into time domain. That is a important things. So you know that already you can do this by using the what you can say that partial fraction method. By using that also you can solve it. Partial fraction only, no? If I am not wrong, you can correct it. So by partial fraction method also you can able to convert the S domain into time domain. Okay. Lastly, you can use the Laplace domain, inverse Laplace. But before that, you can find out the coefficient by using partial fraction. So theoretical points is not necessary here, but I will tell what is the exactly time domain behavior, because actually when the theory paper based on the what we can say fully description, then and in that question paper or previously if you are referring the question papers of the university, the fixed question everywhere in the every examination there is a fixed question based on the time domain behavior, minimum 4 marks, maximum 6 marks. So that will be that totally problematic, and we require to plot the pole zeros, we require to find out the coefficients, and then we have to use the inverse Laplace. So all those things are present, so we can take the examples based on that, but MCQ will be the rarely asked based on the those numerical problems. Okay, so still we can complete it because this point is required in the most of the concept here, especially in the controlling the various systems, or we can find out the time domain response, because based on the time domain only we can analyze the signal. So in the DSP it is required, in the control system it is required. So for the given network function N of S, for given network function N of S, a pole zero plot can be obtained or can be drawn, which gives, I will make it pole zero underline. From given network function N of S, a pole zero plot can be drawn, which gives useful information regarding critical frequencies, then comma stability, stability of given system. Okay, means if we are plotting the poles and zeros, and if all poles and zeros lies in the left hand side of the S plane, then we can say that the given system is fully stable. If some poles or zeros lies on the imaginary axis, we can say that the system is marginally stable. If a single pole or zero will come in the right hand side, then we can say that the given system is unstable. Okay, like this we can predict the stability. So this will be the pole zero plot. On x-axis, we can take the real part of the complex frequency, that is sigma n, Napier frequency we can consider. On y-axis, j omega n, that is angular frequency. 0. Okay, so here suppose -1, -2, -3, -4. Here it is 1, 2, -1, -2. Here it is 1, like this. So if we are plotting the poles anywhere, okay, poles and zero, suppose this is the 0, 1 0 is present at here, 1 0 is present at here. Now poles we can consider. So pole, suppose it is present over here. So poles must be lies, if complex poles will be there, that must lies in a pair, that is a complex conjugate. Suppose here is one pole. Next one, you can consider, suppose here is one pole. So here one. So these are the poles and zeros example we have taken. Okay. So here we can easily classify which are the complex conjugate poles, which are the simple poles, which are the simple zeros. So S1 and S3, I will give the name S1 and S3 are the complex conjugate poles. Complex conjugate poles. ओके, आता तुम्ही म्हणणार S1 S2 कुठे आहेत, S1 S2 S3. So S1 we can call it as based on the real part. So S is equal to -1 means this is the S1 pole. हा तुम्ही जर पॉझिटिव्ह S1 घेतलात तर हा काय असणार आहे S1 स्टार. S1 स्टार म्हणजेच कॉम्प्लेक्स कॉन्जुगेट. ओके, नेक्स्ट S3 based on the real part, this is S3, this is S3 star. Okay, next one, where is the pole at S is equal to 2, that is S2, we can call it as, this is S2. Now similarly we can consider S0 and S4. Sorry, S2 I will write first of all. This is what real pole, because only it is having real part. Okay, next S0 and S4, these are the real zeros. Okay, so S0 and S4. So this is, I will give the name as S0, and this I will give the name as S. So here we have to use the labeling, we have to use the names for the poles and zeros. That is required for understanding the time domain behavior of the given system based on the pole zero plot. So we have to give the names S1, S2, S0, S1 star, like this. Okay, so this will be the background, or this will be the introduction part required for understanding the time domain behavior of the given system. Next, consider, next point, consider a network function. Consider a network function. So I will consider any name now. It may be voltage signal, it may be current signal, it may be impedance. So I will consider the current signal. I of S is equal to P of S divided by Q of S. Okay, so this may be written as, म्हणजे polynomial है P of S and Q of S. This may be written as, so already we are discussing the poles and zeros. So I of S is equal to H into, H is the scale factor. Okay, that is nothing but B0 divided by A0, or A0 divided by B0, that already we discussed. Now the factors we can, after factorization of P of S polynomial, S minus SA. Actually in there we have taken S1, S2, S3 up to Sn, and in the denominator s minus s1 s for the poles we have taken, okay, in the previous part. So here we can take for the numerator s minus sa, s minus sb dash dash into s minus sn, where n number of zeros are there, divided by s minus s1 we can take s minus s2 dash 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 up to s minus sm, where n is number of zeros and m means number of poles. Okay, so we can consider this will be equation number 1. So s1 s2 up to sm, these are the poles, and sa sb sn, these are the zeros that we can know that. And h is what? Scale factor किंवा scaling factor. ओके, आता मला सांगा, हा एक इक्वेशन आहे जिथं फॅक्टर्स आहेत. सो कॅन वी यूज हियर partial fraction? Who will tell what is the partial fraction method? S minus s1, s minus s2, here multiplication is there of the poles. So how to use the partial fraction here? So check here whether it is correct. I of s is equal to k1 upon s minus s1 plus k2 upon s minus s2 plus k3 upon s minus s3 plus dash 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 up to plus km upon s minus sm. So this is the second equation. So this is what we can say, that the given network fraction by using partial fraction we can convert into this. So where k1, k2, k3 are the coefficients, that coefficients we can find out. Okay, that coefficient we can find out, and this is in what? Laplace domain. S domain means Laplace domain. So time domain, from the Laplace domain we can get. Okay, time domain मध्ये जर कन्वर्ट करायचं असेल तर काय यूज करायला लागेल आपल्याला? इनवर्स लॅपलास ट्रान्सफॉर्म. So up to this point everyone understood? Yes or no?
Yes.
Okay, so theoretical part आहे, हे काय जास्त विचारणार नाही तुम्हाला कुठं, पण प्रॉब्लेम्स तुम्हाला नक्की विचारणार. ओके, so next point here, the time domain behavior. Here the time domain behavior or response can be obtained by using inverse Laplace transform. So equation 2 is in S domain. So from, if you are applying the Laplace inverse Laplace transform for that equation number 2, then you can get the time domain, that is I of t. In time domain you can get inverse Laplace. So how to apply that I will tell. I of t is equal to inverse Laplace means L raised to -1, that you know. In bracket you can put the equation as it is, k1 divided by s minus s1 plus k2 divided by s minus s2 dash 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 up to km divided by s minus sn. Okay, so for this we are going to apply the inverse Laplace. So I of t, we can get I of t is equal to h into, or sorry, आता इथून प्रत्येक वेळेस कोएफिशिएंट काढावं लागेल. कोएफिशिएंट फायनल केल्यानंतरच तुम्हाला हे फायनल आन्सर मिळणार. पण मी एक एक्झाम्पल दाखवतो. टू फाइंड आउट k1, एक एक्झाम्पल, टू फाइंड आउट k1 कोएफिशिएंट काय करावं लागतं आपल्याला? k1 इज इक्वल टू h इंटू k1 व्हॅल्यू काढायचं आहे. मग हे कधी पॉसिबल आहे? जेव्हा s इज इक्वल टू s1 असेल. ओके, सो इन ब्रॅकेट S minus SA, numerator same in our S minus SB, dash 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 up to S minus SN, divided by S minus S1, S minus S2, dash 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 up to S minus SM, bracket complete, into S minus S1 in our. Okay. So कारण हा S minus S1 हा S minus S1 कॅन्सल होईल. मग बाकीच्या S च्या ठिकाणी बाकीच्या S च्या ठिकाणी तुम्हाला S1 ठेवावं लागेल. ओके, थोडं समजायला जरा अवघड आहे इथं. So this vector and this vector will get cancelled. Now remaining S is replaced by S1. जिथे जिथे S असेल तुम्ही ते S1 नी replace करू शकता. So by putting all those, by putting H value, then you can get the values of K1 here. ओके, म्हणजे आता हे हा पॉइंट मी काय सांगतोय, कारण जेव्हा एक्झाम्पल आपण सॉल्व्ह करूया तेव्हाच तुम्हाला कळेल की हे नक्की काय. ओके, so time being you can try to understand these are all the mathematical expressions, but when we are solving the examples, no numerical examples, to find out the coefficients, then you can easily understand this concept. Okay, so next point will be consider that there are the 6 points, 6 steps we can consider for solving the numerical examples to determine the time domain behavior. So those 6 points we can try to discuss here. ते 6 पॉइंट डिस्कस करायच्या अगोदर आपल्याला एक नोट पॉइंट घ्यावा लागेल. सो नोट पॉइंट वी कॅन कन्सिडर. ओके, सो नोट पॉइंट काय असणार आहे, S minus SN, S minus SN म्हणजे S minus S1, S minus S2, S minus S3. This is what complex frequency. कॉम्प्लेक्स फ्रिक्वेन्सी. मग त्याला काय करायचं, S minus SN is equal to, त्याला काय असणार आहे, magnitude as well as phase. So this is MLN means magnitude. Next e raised to j phi of ln. Okay, so phi means what? Phi means what? Anyone?
MT.
No, phi means what? So you know the complex frequency, complex number. सगळ्यांना माहिती आहे का कॉम्प्लेक्स नंबर काय असते, रियल पार्ट अँड इमेजिनरी पार्ट.
Yes, sir.
From that complex frequency, from that complex number, suppose I want magnitude, how you can find out? Magnitude कसं फाइंड आउट करणार. एक्झाम्पल A plus BJ असं एक कॉम्प्लेक्स नंबर आहे, मला त्याचं मॅग्निट्यूड पाहिजे. हाऊ यू कॅन फाइंड आउट? Yes, how you can find out the magnitude? Whether you studied the complex number, 11वी 12वीला झालेलंच असणार आहे. Yes, anyone? Complex
Yes, sir.
number चा magnitude माहित नाही. Under A square
Square.
plus B square म्हणजेच काय असतं, रियल पार्ट स्क्वेअर प्लस imaginary part square. So this is about the magnitude that is given here. Phi is the phase angle. So how you can determine phase angle? Yes, how you can determine? Whether you know tan inverse of B divided by A. हा फॉर्म्युला माहिती आहे का तुम्हाला?
Yes.
B means imaginary part divided by real part. Phi is nothing but phase angle, that is nothing but tan inverse of imaginary part divided by real part. So that is given here, phi. Now understood? What is M and what is
Yes, sir.
phi? Okay, so here the K1 we can find out. K1, whatever I written the equation in the previous slide. So K1 is, we can find out instead of by using partial fraction, because partial fraction is not allowed for time domain behavior here. We have to follow the rules or steps of determining the time domain behavior according to given in the syllabus. So K1 we can find out H into magnitude means distance, actually distance between 2 points, MLA into e raised, we can consider e raised to j pi of LA, means this is with respect to age 0. Next, into MLB into e raised to 0 phi of LB, like this it will continue, divided by, with respect to denominator means what, with respect to poles, M of L1 into e raised to j phi of L1 into M of L2 into e raised to j phi of L2, like this. So in this way we can find out the value of coefficient K1. So I will put in this box. So here this is with respect to what, zeros, and this is denominator with respect to what, poles. Okay, so this is called as what, residual equation. Residual equation. This is called as what, residual equation, to determine coefficient. To determine coefficient value. हे आता लवकर तुम्हाला समजणार नाही, but when we are solving the first example today, you can easily understand what is this residual equation here. Okay, chalo, now next we can discuss the 6 steps. Those are required to find out the time domain behavior. So next point will be steps to find out time domain behavior, or time domain response. So one by one step we can discuss here. These steps are important because these are useful for solving the numerical example. So first, obtain the pole zero plot. You have to plot, obtain the pole zero plot, obtain the pole zero plot for for given network function. This is the first step. Obtain the pole zero plot for given network function. Next, select one of the pole. Select one of the pole as reference pole. Select one of the pole as reference pole. So in that, measure distances. Measure distances MLA, MLB dash dash up to MLN of a given pole, of a given reference pole from each of other zeros. Each of other zeros. म्हणजे जे तुम्ही रेफरन्स पोल म्हणून घेतलेला असाल एखादा पोल, त्या पोल पासून दुसरे जे झिरोज आहेत, जे झिरोज प्रेझेंट केलेले आहेत, जे झिरोज आपण ड्रॉ केलेले आहेत, त्या झिरोज आणि त्या रेफरन्स पोल मधले डिस्टन्स, समजा 3 झिरोज आहेत, त्या तिन्ही झिरोजचा त्या रेफरन्स पोल पर्यंत डिस्टन्स तुम्हाला कॅल्क्युलेट करायचा आहे. ओके, दॅट इज कम्स अंडर सेकंड पॉइंट. थर्ड पॉइंट, मेजर angle phi LA, phi LB dash 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 up to phi LN of line joining reference pole to each zeros. जसं तुम्ही डिस्टन्स काढलं तसं अँगल काढायचे. अँगल कोणामधला, प्रत्येक झिरो टू त्या रेफरन्स पोल मधला अँगल. रेफरन्स पोल आणि झिरो कनेक्ट करायचं, लाईन कनेक्ट करायचं आणि त्यांचा अँगल तुम्हाला फाइंड आउट करायचं. दॅट कम्स अंडर पॉइंट नंबर 3 और स्टेप नंबर 3. नेक्स्ट स्टेप नंबर 4. आता हे झालं झिरोज विथ रिस्पेक्ट टू रेफरन्स पोल and zeros we have taken. Now with respect to reference pole and remaining poles, so measure distances. आता की इथं काय येणार, ML1 ML2 dash 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 up to MLM, कारण m number of poles असतील, of a given reference pole to remaining poles. रेफरन्स पोल सोडून दुसरे जे काही पोल्स असतील आणि रेफरन्स पोल त्यांच्यातलं डिस्टन्स फाइंड आउट करायचं आहे. नेक्स्ट 5th वन, अँगल. मेजर अँगल phi L1 phi L2 dash 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 phi LM of the line joining reference pole to remaining poles. Okay, that angle you can find out. 6th one, put all those in residual equation to find or to get coefficient K1. Find out coefficient K1. So this is with respect to what? First pole, reference pole. So this is applicable. So one by one you have to consider each pole as a reference pole. आता एक reference pole घेऊन तुम्ही K1 फाइंड आउट केलं, दुसरा रेफरन्स पोल घेऊन तुम्ही K2 फाइंड आउट करायचं, तिसरा 3 असेल तर K3 येईल, 4 असेल तर K4. असे जेवढे पोल्स असतील तेवढे तुमचे कोएफिशिएंट असणार. ओके, सो रिपीट 6 स्टेप्स. रिपीट स्टेप नंबर 2 to 6 for all poles individually by taking as a reference pole. प्रत्येक पोल आपल्याला रेफरन्स पोल कन्सिडर करून हे स्टेप रिपीट करायचे टू फाइंड कोएफिशिएंट्स K1, K2 dash dash up to Km. जेवढे पोल्स असतील तेवढे तुमचे कोएफिशिएंट्स येणार, Km, K1, K2 dash dash up to Km. So these are the 7 steps actually. First steps it is common because without pole zero plot we cannot apply the next steps. So next 2 to 7 steps you have to consider for finding out the time domain behavior. असं कुठलंच एक्झाम्पल नाही ज्यात एकच पोल आहे, कमीत कमी 2 पोल्स असतात. Okay, so you can read it. I will give the 1 minute for you people. You can read it all those points, and if any questions will be there you can ask. So today we have to solve one example also, so that you can understand these all points. So any question? This is actually somewhat the theoretical part, but without understanding theoretical part we cannot understand the numerical example here. So we have to follow the theoretical part first, then numerical. Okay, so at least we can try to solve one example today. We can try to complete it. So I will give the heading here. Numerical examples on time domain behavior. Okay, so question number 1, we can take first a simple example. For the given network function, draw pole zero plot, and obtain time domain response, So I of s is equal to, current signal is given, 3s divided by s plus 1 into s plus 3. So this is the question. This question was asked for 4 marks in the university question paper. So we have to start according to the steps of finding out the time domain behavior. So what is the first step here? What is the first step? Yes, first.
Plot the poles and zeros.
Very good. So first of all, given things, we have to write the network function. The network function n of s, whatever given, that is I of s given here. I of s is equal to 3s divided by s plus 1 into s plus 3. Already given in the factorization form. Okay. आता 3 काय आहे इथं? What is the 3? What is 3?
Coefficient.
What coefficient? That is scale factor, no? That is h value. H is 3 here. बरोबर आहे की नाही?
Yes, sir.
Okay, that is h value. Next, how many zeros are there? Zeros किती आहेत? एक आहे का 2 आहेत? First,
1.
okay, s raised to 1. Okay, so at what value? S raised to, s is equal to 0 केल्यानंतर
0.
कारण इथं काय आहे? इथं नंबर नाही आहे. So yes, only s is there. So equate equal to 0. S is equal to 0 करा ना. मग s is equal to 0 केल्यानंतर काय असणार तुमचा? At location 0 there is a 0. ओके, म्हणजे क्वाड्रेटिक सिस्टीम मध्ये जो ओरिजिन आहे त्या ओरिजिनला एक 0 येणार. नेक्स्ट, पोल्स कुठे आहेत? किती आहेत पोल्स?
2.
एक आहेत का 2 आहेत?
2.
2 आहेत. 2 पोल्स. सो s is equal to -1 आणि s is equal to -3. बरोबर? येस, व्हेरी गुड. आता त्याच्यानंतर तुम्ही पोल 0 प्लॉट करू शकता. त्याच्यानंतर पोल 0 मी प्लॉट करते. मी लेफ्ट हँड साइड जास्त घेतलंय स्पेस, कारण पोल्स अँड झिरोज लेफ्ट हँड साइडला आहेत. So this is the sigma n, this is the j omega n. So this is 0, -1, -2, -3. इथं किती येणार आहे? कॉम्प्लेक्स पोल्स वगैरे काहीच नाहीये. ओके, आता मी पोल 0 प्लॉट करतोय. इथं मी काय करणार आहे? 0 प्लॉट केलंय, एकच 0 आहे. आणि इथं काय? -1 ला एक पोल आहे आणि -3 ला एक पोल आहे. So this is what pole 0 plot. This is what pole 0 plot. Have you understood, everyone?
Yes,
to this
sir.
step. Okay.
Yes, sir.
आता नेक्स्ट स्टेप बघा, मला हा जो नेटवर्क फंक्शन आहे त्याचा मला युजिंग पार्शियल फ्रॅक्शन करायचे. द नेटवर्क फंक्शन I of s can be written as by using partial fraction. ऑलरेडी खाली फॅक्टरायझेशन मध्येच दिलेलं आहे. पार्शियल फ्रॅक्शन याचं कसं येणार आहे, I of s इज इक्वल टू कसं येणार आहे सांगा मला.
A upon S plus 2.
येस, K1 यूज करू शकता, K1 यूज करू शकता किंवा कॅपिटल ए बी, आपण कॅपिटल ए बी यूज करूया K1 K2 च्या ऐवजी. सो A डिवायडेड बाय S प्लस 1 घ्यायचा प्लस B डिवायडेड बाय S प्लस 3. मग ए आणि बी काय आहेत, कोइफिशियंट आहेत, म्हणजेच K1 K2 आहेत. मग हे तुम्हाला त्या 7 स्टेप जे दिलेले आहेत ते यूज करून तुम्हाला ए आणि बी चं व्हॅल्यू फाइंड आउट करायचं आहे. सो दिस इज माय इक्वेशन नंबर 1. दिस इज माय इक्वेशन नंबर 1 हियर. ओके. आता मी काय करतोय, सो नेक्स्ट स्टेप विल टेक 10 to 15 minutes. So instead of that we can stop today here. So in the next lecture we can continue to find out the A and B value. Okay. So we can stop for today. By partial fraction you can solve it. By partial fraction you can try to solve the value of A and B you can find out. आता हे कसं सॉल्व करायचं ते तुम्हाला माहिती आहे. इथलं एक इक्वेशन आहे आणि हा एक इक्वेशन आहे. हे दोनचं कॉम्बिनेशन करून पार्शियल फ्रॅक्शन यूज करून तुम्ही ए आणि बी चं व्हॅल्यू फाइंड आउट करा आणि ते मला पुढच्या लेक्चर मध्ये सांगायचं आहे. सो बाय युजिंग पार्शियल फ्रॅक्शन यू कॅन complete the homework and tell me the A and B value. And in the next lecture I will tell by using the steps of residual equation. Okay, I will find out the A and B value. So both answer we can match it so that we can analyze that whether my answer is correct or not. So that part you can take as a homework, and next part we can discuss in the next lecture. So if any questions will be there from today's point of view, you can ask, otherwise we can stop for today. आहेत का कोणाला questions?